Hi, this is a short introduction to the part of Marine Biotechnology course that focuses on high value-added products. The value addition is a process that raises the market value of the product over the cost of raw materials and results in a higher profit. The slide presents biomass valorization pyramid. The lowest value is assigned to biomass that serves as a source of energy. For example, when we burn the biomass to produce heat. Food and feed is of higher value, but biomass is most valuable when it's used to produce pharmaceuticals, nutraceuticals and other fine chemicals for health and lifestyle purposes. Marine biotechnology is defined by its source material, that is, marine organisms and their products. This sector explores marine biological resources in order to develop new products and processes. Marine biotechnology has the potential to contribute to other sectors of biotechnology, such as health, industry, agriculture, and also the environment. The global marine biotechnology market is predicted to grow at a compound annual growth rate (CAGR) of 5.6% during the period from 2018 to 2026, and according to Smiths report, it has the potential to reach $6.4 billion by 2025. It's less than 1% of global biotechnology market, but there are good perspectives for further development of this sector. The important drivers in the market are the increasing demand for biofuel, for new generation of cosmetics, healthcare products, biomaterials and enzymes for industry and research. In this slide, you can see logos of some companies that use marine organisms or marine compounds in their business. The companies are mainly based in North America and in Europe. Even in ancient times, people made use of marine natural resources. Thousands of years ago, sponge skeletons were applied in Egyptian medicine. Sponges were used during surgical interventions to stop bleeding and disinfect wounds. Agar, the jelly substance from red algae, was invented in Japan in 17th century, and since then it has been used as component of many food products. It can be used as an appetite suppressant, a vegetarian substitute for gelatin, or a thickener for soups. You can find agar in ice cream as well as in many other desserts. Food DNA polymerase from the Archaea Pyrococcus furiosus is another example of high value-added product from the sea. This highly thermostable enzyme found wide application in PCR, in polymerase chain reactions. And finally, the green fluorescent protein from the jellyfish Aquaria victoriae. This protein is an important glowing marker in biomedical research and in cell and molecular biology. In 2008, a Nobel Prize in Chemistry was awarded to 3 scientists for the significant contribution to the discovery and modification of this important protein. This protein inspired a German artist to create a sculpture which you can see in the slide. More examples of marine-derived products will be presented during other parts of the course. Marine natural products show a broad range of biological effects, but the cytotoxic and antiproliferative activities against tumor cells clearly dominate. It's difficult to say if this fact indeed reflects the natural function of these metabolites, or is just because the effects on cancer cells were tested most frequently. Marine natural products also show antibacterial, antiviral, antifungal, anticoagulant, anti-inflammatory, and other activities. Majority of the discovered bioactive marine natural products has been isolated from microorganisms and sponges. Predominantly, production of these metabolites occurs in organisms for whom they constitute an element of chemical defense. After the release into water, they are rapidly diluted, therefore, the compounds have to be highly potent to be effective. The number of the discovered bioactive products increases each year. This is due to easy access to marine resources and especially to the extreme environments. According to the report published in 2015, the highest number of marine natural products belongs to terpenes and alkaloids. However, marine peptides are characterized by the highest proportion of bioactive compounds. 40.8% of marine peptides show some kind of activity, while the average for marine natural products is 28.4%. In the following parts of the course, I will present the main stages of the process from marine-derived compound to value-added product. You will learn more about marine anti-cancer and antimicrobial drugs, marine enzymes, cosmetics, cosmeceuticals, nutraceuticals, and functional food.